Sometimes we come up with situations where a function changes partway through, and the best way to describe it is using in pieces. So we call these piecewise defined functions. So a way it would look like is kind of like this, where it's defined for certain values of x, part of the equation is defined for certain parts of x in one part, and different parts of x on another part. So let's take a look at this, and we basically just use our same tools. So if I was to look at this equation right here, we have x squared minus 2. Well, I've got a parabola that's shifted down 2. But this is only true when x is less than 1. So if I look at x as 1 right here, it's only going to be true for the values going in this direction. Then I've got a line, negative x plus 1. Well, I'd be starting at 1, slope of negative 1, and I have my line. But this is only true for these values going in this direction. Now, this one has the equals. So we'll put a solid dot on the line and an open dot on the parabola. Okay, so let's see about how to graph one of these things without going through all those steps. So think about how each one's graphed. Now what's really important is you need to take the transition points and plug those in to make sure you get that point accurate. So I've got an absolute value, so I got a V shape. It's flipped. It's to the left 3. So I'm going to go left 3, up 5. There's my vertex. Now I'm going to plug negative 2 in this equation. Plugging in negative 2, I get negative absolute value, negative 2 plus 3 plus 5. So this gives me 1 inside the absolute value, so I'll get negative 1 plus 5. That's going to give me 4. That was my transition point. So I know it has to go through that point right here. So I'm going to get a V shape, just like this. Now I'm going to go look at this guy, and it's a cubic, so I'm going to get that little twist kind of going on. The inflection point happens when at the point negative 1, negative 1. It's shifted to the left 1 and down 1. So I got negative 1, negative 1. I'm going to plug in negative 2 in this equation. When I plug in negative 2, I get negative 2 plus 1 cubed minus 1. I get negative 1 cubed. Negative 1 cubed is negative 1 minus 1 equals negative 2. So I know it has to go through this point. Now, it's a cubic, so I know my inflection point's right here, so it's going to flatten out at that point and then turn upward. And it's going to start from right here. So I'm going to get some kind of a curve that's going to come across and then start heading upward. And there it is. Now I've got to decide how these both start and finish. Well, I have the equals on the negative 2 right here with the absolute value. So that means I should have a solid dot on this one. Don't have equals in the second one, so that should be an open dot. So solid dot here, and then open dot here. And it's kind of hard to see, so let me get rid of the ink marks. And we can see what our final solution was. Okay, now another part you're going to have to do is maybe have to find the function. I kind of picked out some ones that are a little bit harder to kind of recognize and make a distinction between which one's which, particularly when you only see a piece of the function. So this graph, the one that's in green, you can see it has an asymptote. While the second graph does not. It keeps going. So this is the graph of 2 to the x. This is a graph of square root of x. It's been flipped. So I'm going to start with the 2 to the x one. Now, when we build our function, we start with some kind of a function notation. We use a curly bracket, and then we're going to put one function here and one function here. So for 2 to the x, first thing I would do is think about shifts up and down. I look for my asymptote. This has been shifted up 2. And then I look for the shifts left and right. Look for where this is 1 unit above. That's right here. So this has been shifted up 2 and to the left 1. So when I write my equation, I get left 1 is the x plus 1, then up 2 is the plus 2, and I've got an open dot, so I don't have equals. My transition point was at 1. Now let's look at the second equation. Second equation is a square root graph. I can see it's been flipped. It's right 1 and up 3. So I'm going to have a negative square root x minus 1 and then plus 3. And we have a solid dot there, so the equals goes with it. Okay, another component you may have to do is see about shifting one of these. And we just use the same kinds of rules. So let's say we have this equation. So I've got a parabola. It's shifted to the left 2, up 1. It's going to be true when x is less than negative 1. And then we also have a line. So this is what the graph looks like. So I can see the parabola. It's left 2, up 1. And when I plug in my transition point, look what happens on this one. We have negative 1 plus 2. So this gives me 1 squared plus 1, that's 2. Then when I plug in my negative 1 into the line, I get 1 minus negative 1. That's 1 plus 1 is 2. They both have the same value, so I didn't bother putting any kind of dots. So when we did the parabola, I would have had an open circle, but then I would have had a closed circle here. So if you want to have a dot there to kind of show where they get joined together, that's fine. Or you don't really need one when it's continuous. This graph is continuous because I can draw it without lifting my pen or pencil. Okay, so now I'm going to take this graph and we're going to shift it. So g of x is the graph of f of x minus 2 minus 1. So this tells me that it's been shifted to the right 2 and down 1. So let's look at some of my key points. I'm going to look at the transition point, take it right 2 and down 1. I look at my vertex, take it right 2 and down 1. And I can see about the shift in the graph just like we would any other graph. So that's what the result looks like. Now I'm going to actually find the equation. So we're going to go and plug in this information into the equation. So if I did g of x, I'm going to take the x minus 2 and replace the x on each of the x's, including these x's. So what happens here, I've got x minus 2, that's replace the x, plus 2 squared. Then I had the plus 1. Then I've got minus 1 right here. And this is 4. I'm replacing the x with x minus 2. X minus 2 is less than negative 1. Now I'm going to do the same thing with this one. We had 1 minus, in parentheses, I replace the x, and then I got minus 1, and this is 4 x minus 2 greater than or equal to negative 1. Now when I go to simplify this, I've got x minus 2 plus 2, so I just get x squared plus 1 minus 1, so I just get x squared. There's my parabola. And I've got 1 minus x plus 2 minus 1, so I end up getting negative x plus 2, because 1's basically cancel out. And here I'm going to add 2 to both sides, and I get x is less than 1, and here is x is greater than or equal to 1. Now if I look at my transition point happened at 1. And that's how you go basically about finding a shifted piecewise defined function.